is the angriest part of a 3D figure? The cross section. Come on, you guys. You know you like it. All right, 10-1. Here we go. Solid geometry. This is where we take everything we've learned and we put it all together. Okay? A solid figure, a three-dimensional figure, is a solid. You get 3 dimensions: length, width, and height, also sometimes called your depth. Okay? Three-dimensional figures are made up of 3 different things. We have our faces, which are the flat surfaces of your figure. We have the edges. This is the segment that intersects 2 of those faces, so I'd like to think of those as like the folds here. And then you have your vertex. The vertex is a point that intersects 3 or more faces. Okay, sometimes I refer to these as just the corners here. All right, and I'm going to show you these more concrete examples when we get in class tomorrow. But we have a bunch of different types of three-dimensional figures. The first of which is a prism. A prism is formed by 2 parallel, congruent polygon faces. Okay, in this case, our faces are triangles. These faces are called your bases, and they're connected by parallelograms. Those are called the lateral faces. We have a cylinder. A cylinder is related to a prism because it has 2 bases as well. However, a cylinder is formed by 2 circular bases and then a curved surface that connects those 2 bases. We have a pyramid. The pyramid is formed by a polygon base, so 1 base, and then the faces that connect that base are the triangles. They come together at a common vertex at the top. The next figure is related to a pyramid. It's a cone. The cone also has 1 base. In this case, it's a circular base, and then it has a smooth surface that connects that base and folds together at the top at one point called the vertex. And then lastly, we have the infamous cube. The cube does have 2 bases. Even though all 4 sides are squared around, the 2 bases on the top and the bottom give me 6 square faces total. When we talk about prisms and pyramids, we need to remember that they're named by the shape of their bases. So here we've got prisms. This would be considered a triangular prism because of the 2 triangular bases. A rectangular prism has 2 rectangular bases. Pentagonal prism, pentagon bases. Hexagonal prism, hexagon bases. You get it, right? Likewise, our pyramids also are named by their base. In this case, this is a triangular pyramid, a rectangular pyramid. Sometimes we call it a square pyramid because sometimes you don't know whether or not it's a rectangular or square. Pentagonal pyramid, hexagonal pyramid, you get it, right? Now we can classify the figure by doing the following things. We're going to name it, put the vertices down, the edges, and the bases. So if I wanted to name this first figure, this would be a rectangular prism. I know that because I've got 2 rectangles for my base. Okay, vertices. Now remember, your vertices are the corners. Okay, name the vertices. Well, I have 1, 2, 3, 4, 5, 6, 7, 8 of them. They are A, B, C, D, E, F, G, and H. Edges. Edges, remember, where the faces come together. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 edges. There's going to be a lot of these. We've got A, B, B, F, F, E, E, A. Okay, then we can go across B, C, and A, D. Then we can do C, G, G, H, H, D, D, C, and then go across the other way. F, G, and E, H. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then we just said this has 2 bases. Okay, we have rectangle A, B, C, D, and rectangle E, F, G, H. Okay, it seems like a lot, and most of the time I just ask you for the number of vertices, edges, and bases. But in this example here, I just wanted to make sure that you understood exactly what each piece is. I would like for you now to complete the second one, classify it. So I want it named, the vertices, the edges, and the bases, please. Okay, so you should have named this a pentagonal pyramid. You should have had 6 vertices. You should have named them A, B, C, D, E, and F. You should have had 10 edges, A, B, B, C, C, D, D, E, A, sorry, and then each one went up to F, so that's 10. And then there's one base, and that base is this pentagon, A, B, C, D, E. All right, so each three-dimensional figure has its own net. I want you to think net captures something, right? When you pull it together, it has the piece or whatever you wanted, whether it's a butterfly or a fish, okay? Whatever it is, it captures it and holds it inside, right? A net for a three-dimensional figure is pretty much the surfaces of your three-dimensional figure that could be folded to form that figure. So if I wanted to identify it, looking at a net, you're going to look at the number of faces, and then you want to try and figure out what the shape of each base is. Okay, so if you take a look, describe the three-dimensional figure that can be given from the net. If you look at A, this is your net. So when I fold it up to capture the image, I hope you see that each is a square, and there's 6 of them, so this would have to be a cube. The next one, we've got a figure with one circle, and then this piece that if you were to fold it, would fold around here and come to the top at this little point. The only figure that we've talked about that has one circle in it is our cone. The last one, we've got 3 triangles here and then a different shaped triangle at the bottom. Well, if I fold this up and capture the picture, it is a triangular pyramid. All right, the last thing that I want to talk to you guys about is something called a cross section. I want you to think of this as if I were to take a figure and slice into it with a sheet of paper, okay? So I want you, to describe the cross section of the three-dimensional figure in a plane. So if I cut through this cone with a sheet of paper and I get the very top of it, the image that's going to be left over on that plane is just simply a point. That's the cross section. What image is left over on your sheet of paper, on your plane? So in B, if I slice through, the image that's going to be left over, well, it's the same shape as the base. This is going to be a pentagon. And last one, if I slice through this cylinder here, the shape that's going to be left over here is going to be a rectangle. Now, things happen whether or not you cut parallel or perpendicular to the base. If you take a look at this, it says a slice of cheese is a prism with equilateral triangular bases. How can you slice the cheese to make each shape? Well, if I want to slice the cheese, so if I want to cut this with this plane here so that I have an equilateral triangle left over, if I want the same shape as the base, I have to cut parallel to the base. If I cut parallel to the base, I end up with the same shape. In this case, I want a rectangle, so I want the shape of these lateral faces here. If I want that, I will have to cut perpendicular to the bases. All right, this last piece is just kind of fun. Okay, all I want you to do is draw and label a figure that meets the following description. A regular pentagonal prism with side lengths of 6 and a height of 8. Regular, remember, means that all sides and all angles are congruent. So I want you to just practice drawing three-dimensional figures. So just to kind of work through this together, and I'm not sure if you have a ruler with you or not. If not, just sketch it. Remember, to give it that feel that it's three-dimensional, you want those lines that are in the back to kind of sort of disappear a little bit. So if I draw my first base, this will be the top base. Remember, it's a pentagon. All the sides have to at least look like they're the same, right? I'm not the best drawer, especially on here. Now, the one below it, remember, this is prism, so we've got 2 bases. The one below it, I'm going to put those as dotted lines, just because, like I said, I want you to create it so that it's going back into the figure. We're going to connect it here, and then we connect them here, 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 and here. Now, like I said, if you have your ruler, you would have been able to do this a little bit more accurately, but you should label your side lengths of 6 inches, and the height of your figure should be 8 inches. Okay? So practice, you guys. You want to practice drawing these figures because you're going to have to draw them a whole bunch of different views in different ways. Make sure you come with questions, please. We'll see you tomorrow.